Okay, so we did the review. So we should be sort of done. Well, we could talk more about rhetoric, but technically we're sort of done with the basic outline of what to do. Now, when you get to the back of the manual, the user manual for the human brain, how to do thinking, we get to the troubleshooting section. Now, what not to do, or rather, what could possibly go wrong. Quite a bit can go wrong. Why should we pay attention to what we want to not happen? Like in a lot of sports, thinking about what you want to not happen is not good. Your subconscious will sabotage you, and you'll miss the basket if you're thinking about missing the basket. So why should we spend a lot of time talking about what not to do? Well, thinking tends to require a lot of troubleshooting. So if you've got a mess and you're trying to fix the mess, it helps if you have some good labels for talking about specific little patterns within the big mess. Definitions of a library of known bugs, definitions of little problems, convenient label descriptors for problems that people have seen before. So that way, when you run into the same or a very similar problem again, you don't have to describe the whole thing from the ground up. That would be hard, that would be time consuming. It's better to have labels and then proceed reasoning by analogy. Hey, this problem's a lot like that other one we solved yesterday. Oh, well, maybe it's not exactly the same, but we can solve this one a lot quicker by bringing the experience from yesterday's problem. So for problem solving and troubleshooting a mess, it helps to have a lot of labels for frequently seen subproblems. A diagnostic bestiary of all the crummy things that are out there. So, an encyclopedic chapter. We'll try to go through only We'll try to skip some of the smaller random details because there's too many of them. A lot of critical thinking books, most of the book is this chapter, a encyclopedia of things not to do. A lot of critical thinking books are basically compendiums of fallacies. Don't do this, this is bad thinking, this is a trap, don't do that. And a real long list where they'll describe a problem for a few pages, go on to the next one, the next one, the next one, and there might be 50 different fallacies. You read through all 50 or so, 200 pages later, you finish the critical thinking book. In my opinion, that's not a program, that's a patch. Just having a bunch of bug fixes is not an operating system. You need to apply bug fixes to something. And generally the assumption is, oh, everyone knows how to think, they're just making a few specific little mistakes. And a lot of critical thinking books tend to be little patches intended to fix bugs in a pre-existing thinking operating system. Well, what if the operating system's like Windows Vista or something, or Millennium Edition, and the operating system is just a giant mess, and you're trying to polish a turd, and you can't get all the bugs. So with this course, I tried to have a more from the ground up approach to critical thinking. And so the what can go wrong fallacy index is just one little one rather long chapter near the end. Why do we need to bother with it so much? Well, the most obvious reason is the self-defense perspective. Sometimes people will try to deceive you, and you're less likely to be deceived if you have it in your vocabulary labels for a bunch of common thinking errors. Those errors are less likely to trick you if you've seen those errors before and know names for them. Also, if you can explain to the deceiver back why their reasoning was wrong, they might notice that you're not someone who's likely to be deceived and move on. That's the self-defense perspective on fallacies. And maybe it's true some of the time, but moreover, a lot of the deception that goes on is not intentional. People don't only have bad thinking when they're trying to trick someone. We're masters of self-deception. We trick ourselves into thinking our bad thinking is correct very frequently. What it's probably more like imagine you have a restaurant. The self-defense perspective on fallacies is like having a good accounting system so that one employee doesn't steal some money. Yeah, that's a good reason to have an accounting system. That analogy, I think, is a very partial match to the real-world situation of thinking. The situation of cognition in human society is probably more like this restaurant. Imagine a small business. They've got to do some bookkeeping. There's money managing, going in and out. There's a lot of accounting that needs to happen. But pretend we have no computers. And we don't even have adults that are good at arithmetic. So it's all either me or, well, you probably don't know how bad I am at math and memory. So pretend all we have for accounting are a bunch of 8-year-olds trying to do arithmetic with a pencil and paper. Now, 8-year-olds know how to do basic arithmetic functions. Technically, they conceptually know what addition, subtraction, multiplication, division, and decimal notation are. We have all the tools. They passed the arithmetic course, just like you're going to pass the critical thinking course. But just because they have a conceptual reach and know what they're trying to do, doesn't mean they never make mistakes. In fact, they make a lot of mistakes. So we have this small business and we're trying to keep the accounting working, but we know that all our accountants are very error prone. They're 8-year-olds with pencils and paper trying to do all the arithmetic. Yeah, they can do it, but it's very error prone. And so if you were the head of the accounting department there, you would want a lot of cross-checking. Chances are, even the 8-year-old with the pencil and paper does the mathematical operation correct more than by chance. Like, if you took 10 of them, you might get a few different answers, but the answer numbers aren't generated randomly. Almost all of the time, the most frequently generated answer is the correct answer. So if you just made the process massively redundant, you could still be reliable, even though each of the individual operators and steps are very error prone. Like, actually, this is sort of what it looked like at Los Alamos when America was inventing the atomic bomb in the early 1940s. Computers were just being invented at this time. So they didn't really have many computers to do math for them. They were just getting the first ones just as they were doing this project. So usually, when you said, uh, get me a computer, you wouldn't get a machine, you would get a person. Hi, I am the computer. Like, I am the accountant. I am the person who does the computation. You'd get a person. So they got a few electromechanical adding machine computers, but most of their computers were people. Hi, I'm the new computer. What's the math problem? And so they were trying to make a nuclear bomb while they were having their calculations done by people by hand. And so they actually had to have a very good process of error checking. Literally, the management would assign multiple people to each problem in a very redundant manner, and then repeat the calculation until they had a consensus, and then only feed consensus answers into the next step of the equation. Complicated, but it can be done. Whether we're trying to make an atomic bomb just by adults with pencil and paper, or trying to do bookkeeping at a small business with only small children as accountants. And I think that kind of not hopeless in the long run, but very error prone at the micro level situation is what human cognition really looks like. And so at Los Alamos, they were error checking all the time. Part of the. Well, people do ask why the Americans got the atomic bomb first. Because they weren't the only ones working on the project. Of course, we have a small sample size there. The atomic bomb was basically only invented once, and then once it's been invented once, you get a few spies in and copy a lot of the material. So there was only one set of people who invented it first. Small sample size. But the general feeling is that the Los Alamos crowd was the best. They were the most open calculation society. They were relatively the most caring about results rather than about preserving their jobs, egos, or lives. They were very friendly to error checking, even obsessive about it, intentionally assigning multiple people, assuming to do the same thing, assuming that like almost half of them are going to be wrong. Even with the best minds in like half the world, they're like, well, this is really hard stuff. Even the smartest people are going to be wrong a real lot of the time. And that there's a general feeling that humility was a large part of what allowed the Los Alamos group to figure out making an atomic bomb when everyone else was still years away. And so error checking is very important. We're masters of self-deception. Critical thinking is largely about error checking in your own head. Error checking outside of your own head That depends it's probably still needed. The practicality of it depends a lot on the cultural situation that you're in. Um, there 2 videos ago, we looked at the um, how to ask questions the smart way article, and that was pretty restricted to the culture of online forums, inhabited mostly by people who don't know each other, hardly ever, if ever, see each other, and have no formal or hierarchical control over each other. And so the consequences of looking incompetent or mean are almost non existent. Really, all they can do is not reply to you or maybe banish you from the forum. Uh, Potential for punishment is just non association. And there really isn't much potential for reward either. Like, no one's getting really paid for this stuff. And so, internet forums are a very open society that's very agile with critical thinking and error correction. Like, the main subject matter focus of that article was software debugging, which is really just a lot of error correction. Of course, in the physical world of most human societies that have ever existed, we need to not piss people off or lose our jobs or get ourselves sent to jail for pissing more people off upon whom we depend. And so self-preservation incentives often conflict with scientific, logical error correction incentives. Some would posit that reducing the further we can that a reduction in that hierarchy maintaining conflict of interest or between maintaining an image as a competent person who doesn't make a lot of mistakes or isn't just evil versus getting good answers and correcting mistakes. One might posit that reductions in hierarchies in a more open would produce a culture of quicker error correction, and that could be seen as the core positive of Popper's open society. Of course, we don't always live in such open societies. Every little subculture is different, but that's sort of the reasoning behind the reasoning that makes these uncivic, intensely nerdy subcultures not extinct. These types of subcultures wouldn't exist if they didn't have some advantages in some areas, which I think would be, and I think the advantage that would exist is quicker and more robust error correction, getting one to innovation and consonance with realities quicker. There certainly can be a lot of costs to social cohesion and identity, which is why in the How to Ask Questions the Right Way article, the author's like, most people, you should probably think of us as slightly brain damaged in some way when that'll help you interact with us and deal with our quirks and asking questions. Possibly inhuman, but I never promised that critical thinking's a human trait. Like, how much do you think you're gonna get out of this course?